GFCI breakers or outlets alone are unlikely to completely prevent fires caused by window AC units. GFCIs detect ground faults. They trip when current flows through an unintended path, such as through water or the body. If a short occurs within the motor or condenser, it may not create a ground fault that a GFCI would detect. A short circuit in the motor will cause a high return amperage, which will eventually trip the circuit breaker portion of the GFCI. However, this may not be fast enough to prevent a fire. To mitigate possible causes, ensure drain holes and filters are cleaned to prevent water accumulation in the drain pan. Check if AC units are properly sized for the area they are cooling. Oversized units may run too hard and overheat. Inspect wiring and connections within the AC units for any loose or damaged components. Consider installing surge protectors to protect AC units from voltage spikes that could damage their circuitry. Keep portable fire extinguishers nearby in case of emergencies. RCD outlets provide more sensitivity in GFCI breakers, 3 mA versus 30 mA. However, they are more expensive and require rewiring. SI breakers are specifically designed to detect arcing faults, which can be a cause of electrical fires. If possible, consider upgrading electrical panels to accommodate SI breakers or RCD outlets. While GFCI breakers may provide some protection against ground faults in window AC units, they are unlikely to prevent all fires caused by other factors such as shorts within the motor or overheating. A comprehensive approach involving proper maintenance, surge protection, and fire extinguishers is recommended to minimize the risk of electrical fires. Consult with a qualified electrician for further guidance and assessment of the specific situation. Understanding how GFCIs work is crucial. They constantly monitor the current flowing in a circuit. If there is an imbalance of more than a few milliamps between the outgoing and returning current, it indicates that some current is leaking to ground, meaning it is flowing through an unintended path. This could be through a person touching a live wire, or through water creating a path to ground. The GFCI quickly trips the circuit, cutting off the power and preventing electrical shock. However, a short circuit within the motor of an air conditioner may not create a ground fault. Instead, it creates a direct path for current to flow, bypassing the normal circuit. This results in a very high current flow, but it is contained within the circuit and does not necessarily leak to ground. In this case, the standard circuit breaker, rated at typically 15 or 20 amps, is designed to trip and interrupt the circuit. The problem is that standard circuit breakers are designed to protect against overcurrent, not ground faults, and may not react quickly enough to prevent a fire from starting, especially if the short circuit is small or intermittent. The constant nuisance tripping is also a concern. The high humidity and water accumulation can create minor ground faults that are enough to trigger the GFCI breakers. This indicates that there are underlying issues that need to be addressed, such as damaged wiring, poor insulation, or water leaks. It is important to find and fix the root cause of these problems rather than simply relying on GFCI breakers to protect against them. When selecting GFCI breakers, it is important to choose ones that are specifically designed for the application. Some GFCI breakers are more sensitive than others, and some are designed to be less prone to nuisance tripping. It is also important to ensure that the GFCI breakers are properly installed and tested. They should be tested regularly to ensure that they are working correctly. Addressing condensation and clogged filters is paramount. Regularly clean the air filters in the AC units to prevent them from becoming clogged. Clogged air filters restrict airflow, which can cause the AC unit to overheat. Ensure that the drain holes in the AC units are clear and unobstructed. This will allow water to drain properly and prevent it from accumulating in the drain pan. Consider installing drain line extensions to direct the water away from sensitive areas. Inspect the AC units for any signs of water leaks. Repair any leaks promptly to prevent water from damaging the unit or creating a safety hazard. Ensuring the AC units are appropriately sized is equally vital. If an AC unit is too large for the space it is cooling, it will cycle on and off frequently. This can put stress on the unit and cause it to overheat. If an AC unit is too small for the space, it will run constantly and may not be able to cool the space effectively. This can also cause the unit to overheat. Consult with an HVAC professional to determine the appropriate size AC unit for each space. Regarding electrical faults, carefully inspect the wiring and connections within the AC units for any loose, damaged, or corroded components. Repair or replace any damaged components immediately. Ensure that all electrical connections are tight and secure. Use wire connectors that are appropriate for the size and type of wire being used. Protect AC units from voltage spikes by installing surge protectors. Voltage spikes can damage the AC unit's circuitry and cause it to fail. Surge protectors can help to protect the AC unit from these voltage spikes. Consider installing a whole house surge protector at the main electrical panel. This will protect all of the electrical devices in the building from voltage spikes. Keep portable fire extinguishers nearby in case of emergencies. Ensure that the fire extinguishers are properly sized and rated for the type of fire that could occur. Train personnel on how to use the fire extinguishers properly. Conduct regular fire drills to ensure that personnel are familiar with the fire safety procedures. Considering RCD, also known as residual current devices, outlets, they offer a higher level of sensitivity than GFCI breakers, typically tripping at 3 mA compared to the 30 mA of GFCI breakers. This increased sensitivity can provide better protection against electrical shock. However, RCD outlets are also more prone to nuisance tripping, especially in environments with high humidity or electrical noise. RCD outlets are more expensive than GFCI breakers and require rewiring of the electrical circuits. This can be a significant expense, especially for a large number of AC units. SI breakers, also known as arc fault circuit interrupters, are specifically designed to detect arcing faults, which are a common cause of electrical fires. Arcing faults occur when electricity jumps between two conductors, creating a spark or arc. SI breakers can detect these arcs and trip the circuit, preventing a fire from starting. SI breakers are not designed to protect against ground faults. They are designed to protect against arcing faults. Upgrading electrical panels can be a significant expense, but it may be necessary to accommodate SI breakers or RCD outlets. Consider the long-term benefits of upgrading the electrical panels, such as increased safety and reliability. Consult with a qualified electrician to determine the best way to upgrade the electrical panels. A comprehensive approach that addresses all of the potential causes of electrical fires is the most effective way to minimize the risk of electrical fires. This approach should include proper maintenance, surge protection, fire extinguishers, and the use of GFCI breakers, RCD outlets, and SI breakers where appropriate. Consulting with a qualified electrician is essential. An electrician can assess the specific situation and recommend the best course of action. They can also install and test the electrical equipment to ensure that it is working properly. Firstly, regular inspections of the AC unit should be done. Inspect the AC units regularly for any signs of damage or wear. This includes checking the wiring, connections, and other components. Secondly, any damaged or worn components should be repaired or replaced immediately. Neglecting to repair or replace damaged components can increase the risk of electrical fires. Thirdly, the area around the AC unit should be kept clean and free of debris. Debris can accumulate around the AC units and create a fire hazard. Fourthly, the AC unit should not be overloaded. Overloading the AC units can cause them to overheat and start a fire. Fifthly, extension cords should not be used with AC units. Extension cords can overheat and start a fire. Sixthly, the AC unit should be grounded properly. Grounding helps to protect against electrical shock and fire. Seventhly, smoke detectors should be installed near the AC units. Smoke detectors can provide an early warning of a fire. Eighthly, a fire escape plan should be in place. In the event of a fire, it is important to have a plan in place to evacuate the building safely. Ninthly, the staff should be trained on fire safety procedures. Staff should be trained on how to use fire extinguishers and other fire safety equipment. Tenthly, the fire safety equipment should be maintained regularly. Fire extinguishers and other fire safety equipment should be inspected and maintained regularly to ensure that they are in good working order. The continual tripping of the 30 mA GFCI breakers points towards ongoing ground fault issues. While these breakers offer a degree of protection, their sensitivity means they are likely reacting to minor current leakages which, while not immediately dangerous, indicate underlying problems. These problems need identification and rectification for true fire prevention. The 30 mA threshold, while standard for GFCI protection, is set to prevent electrocution, not necessarily to preempt all fire risks. A smaller current leakage, perhaps due to dampness or degrading insulation, might not trip the breaker but could still generate enough heat over time to ignite nearby flammable materials, especially given the sandy and potentially dusty environment. The investment in GFCI breakers is not entirely wasted, as they do provide a layer of safety against ground faults. However, they shouldn't be seen as a complete solution. It's more accurate to consider them part of a multifaceted approach. The key lies in a combination of preventative maintenance, enhanced detection methods, and prompt response capabilities. A more granular approach to detection could involve integrating sensors that monitor temperature and humidity levels around the AC units. Abnormally high temperatures could indicate an overheating issue, while increased humidity might signal a condensation problem. These sensors could be linked to a central monitoring system, providing real-time alerts and enabling proactive intervention. Regular thermal imaging scans of the AC units could identify hot spots indicative of electrical faults or overheating components. This allows for early detection and repair before fire ignites. Beyond technical solutions, human intervention is crucial. Implementing a rigorous inspection and maintenance schedule with trained personnel to identify potential hazards can significantly reduce the risk of fires. This includes checking for loose wiring, damaged insulation, and proper drainage, as well as ensuring the units are clean and free of obstructions. Quick response is essential in containing any fire that does break out. Strategically placed fire extinguishers, coupled with trained personnel, can help to extinguish small fires before they escalate. Additionally, a clear evacuation plan and regular fire drills can ensure the safety of personnel in the event of a larger fire. Given the conditions, explosion-proof AC units should be considered. Explosion-proof air conditioners are specifically designed and manufactured to withstand and contain an internal explosion without causing external hazards. These units are essential for environments where flammable gases, vapors, or dust are present. The key components that make explosion-proof air conditioners safe are a rugged enclosure, explosion-proof components, and temperature control. The enclosure must be robust enough to contain an explosion. Explosion-proof components include motors, switches, and wiring. Temperature control is important to prevent overheating. The choice of electrical protection should be based on a comprehensive risk assessment that considers the specific hazards present in the environment. It is always recommended to consult with qualified professionals to ensure the safety and compliance of the electrical installations. Regular maintenance should be performed to ensure that the air conditioner is operating safely. The maintenance should include checking for any signs of damage, wear, or corrosion. Any damaged parts should be replaced immediately. The environment that they are in, there is blowing sand which gets into everything. Proper sealing of the electrical components is important. There should be an investigation into the root cause of the fires. There may be damaged wires that are not visible. All connections should be checked to make sure they are tight.